In this video, I explain you a types of combustion chamber for a petrol engine or a SI engines. Now, first we understand what is the combustion chamber. So, combustion chamber is the space above the piston when the piston is at the top dead centers, and this combustion chamber shape is different according to the shape of the piston, according to the position of the inlet valve and the exhaust valve, and according to the shape of the cylinder heads. So according to the consideration, that is a different type of the combustion chamber that we study in the detail. So first we understand, it may be noted that these chambers are designed to obtain the objectives, namely means this combustion chamber is designed for basic purposes: a high combustion rate at the start, a high surface to volume ratio near the end of burning, a radar centrally located spark plug. When the spark plug is located centrally, the flame distance is reduced. That we already study in a design aspects of a combustion chamber. So these things are required for a better performance of the engine. Now first type of the combustion chamber is a T-head type combustion chambers. So here I show you this image. Okay, its name is T-head. What is a head? Head means cylinder head, means upper part of the engine cylinder. It is known as the head. So shape of the head is look like T. So here you see that it is a horizontal and this is the vertical parts. So it make the T shape. That's why it is known as the T-head types. In this image you see that inlet valve is installed on the left side, exhaust valve is located on the right side. So major disadvantage of the T-head type is that we have required two separate camshafts for operating the inlet valve and the exhaust valve. So this was first introduced by a Ford Motor Corporation in 1908. This design has the following disadvantages. First, it needs the two camshafts to operate each valve separately. So generally this valve is operated by using the cam mechanisms, and that cam is connected with the crankshaft. So this is a piston, connecting rod, crank and crankshaft. So motion of the crankshaft is transmitted to this inlet valve by using the various mechanisms, or it is known as the camshaft mechanisms. Okay. So for operating that we require the two camshafts, so it's increased the cost, and also there is a problem in the arrangement of the inlet and exhaust valve. Long flame travel, therefore it has more tendency to denote, means it's create the more noise, and compression ratio were limited to 5:1. So you see in this image the spark plug is located here. Okay, so according to the design consideration, the spark plug is at the centers, so flame travel distance is reduced. So in this case the spark plug is provided here, so flame generated is move up to this region, so flame length is increased. Okay, so this is a disadvantage according to the theory of design consideration. Third disadvantage, has high surface volume ratio, which further increase the knocking tendency, means increase the noise. Now before moving ahead of the second type, I request to like the video if you understand, and also subscribe the channels if you not subscribe, and also go to the playlist for watching the various video related to the mechanical engineering. Next is the L head type combustion chamber, means this engine is look like the L shape, this head. Okay, that is a reverse L. So this is the vertical part and these horizontals. So if you rotate this image, then it's look like the L. Okay, so it is the modification of the T-head type combustion chamber. It provide the two valve on the same side of the cylinders, means both the inlet and exhaust valve is provided on the one side. Okay, so this is the front view. So you cannot see the two valve, it is only one is located. So inlet valve, and outside of this another valve is provided, that is a inlet as well as the exhaust valve. Okay, so next we understand through the top view, so you can understand easily how the valve is located, and the valve are operated through tappets by a single camshaft. So in this L type we require only one single camshaft. So constructions and manufacturing become simple and compact. In a T type, disadvantage is that two camshaft is required, so this disadvantage is avoided in a L type. This was first introduced by Ford Motors in 1910 to 1930. and was quite popular for some times. And these designs has an advantages both from the manufacturing as well as for a maintenance point of view. So this is the top view. Here you see that one is inlet valve and one is exhaust valve. This is the cylinders, and inside the cylinder this is a piston. So you need to understand this inlet and exhaust valve theory. So valve mechanism is simple and easy to lubricate because one camshaft is used. So it's reduced even the cost of the engine. Detachable head, easy to remove for cleanings and decarburizings without distributing either the valve, gears and the main pipework. Okay, means head is easily removed without disturbing either the valve gears and the main pipework. Valves of larger size can be provided. The valve have the larger size is provided in this type. Now what is the disadvantages? The fresh charge has to take 2 right angle turns. 2 right angle turn means suppose this is the inlet valve. From this inlet valve charge is enter. So charge is moving this vertical direction, then 10 right angles means move to 90 degree. So here to here 90 degree move, then moving here and again take the turn at 90 degree means it's a 2 time take the right turns, which result into the velocity loss and hence turbulence is increased, which increase the tendency of knocking. Flame traveling distance is more, therefore knocking tendency is more. Extremely sensitive to ignition timing due to the slow combustion process, valve size is restricted. Thermal failure in the cylinder block also. So chances of thermal failure is also in this cylinder block. Now next is the Ricardo turbulence head, or it is also known as the side valve combustion chambers. So this is the image. So it is also similar as the L shape. Okay, but this cylinder head this shape is changed. In a L type it is a straight, but in a Ricardo type its shape is the curvatures. Okay, so this part is known as the combustion chambers. Here the valve is provided and this is the spark plug. Ricardo developed these heads in 1990. His main objective has to obtain the fast flame speed and the reduced knocking in L designs. So it is the modification of the L designs, and the difference is that it's reduced the fast flame speed, so the knocking is reduced. In a Ricardo designs, the main body of combustion chamber was concentrated over the valves and leaving slightly restricted passage and communicating with the cylinder. Now what is the advantages? The combustion chamber provide the high turbulence because this curvature shape is also helpful to create the high turbulence, because at the top dead center positions only a thin layer of charges exist. Means when the piston is on the top dead center, this space is smaller. Okay, means the thin layer of charges exist between the piston crown and the combustion chamber. So this is the pistons and this is the combustion chamber. So small thin layer is available. So due to this, whole charge is pushed back in the combustion chambers during the compression stop. Therefore it provides additional turbulence. Combustion chamber ensure a more homogeneous mixture of fuels. Homogeneous mixture means it is completely mixed fuel and air by scoring away of layer of started gas cycling to the chamber walls. The piston comes in a close contact with the combustion chamber, means this piston is come close to this combustion chamber's head. In these designs, it reduces the effective length of flame travel, means flame travel time is reduced, hence the tendency of detonation is also reduced. Next advantage, because of contact of piston with the chamber, the mass of end gas is negligible, means during the exhaust time the majority of the gases go through the exhaust valve to the atmosphere. Therefore impact of detonations will be negligible even if detonations occur. The detonation tendency is further reduced since the end gas is a thin layer. If suppose the exhaust gas is not leaving, then the layer of the exhaust gases is very thin. So it is cooled by comparatively cooler cylindrical head. Spark plug is centrally located in the combustion chambers, the length of flame travel is reduced. It results into reduced tendency of denoted. Next is the overhead valve or I-head type combustion chamber. Overhead valve means valve is provided at the overhead positions in a upper parts. Okay, so this is the cylinders, this is the piston, this is the connecting rod. Here the spark plug is provided and the valve is provided in a center part of the cylinder head. This type of combustion chamber has both the inlet valve and exhaust valve located in the cylinder heads. In earlier case, we see that the some valve is located on cylinder head, some is located on the bottom side. Okay. Overhead engine is superior to the side valve engines at the high compression ratio. Means it is better than the side valve engines. In earlier case, we said the valve is provided on the sides, so it is better than the side valve engine. Now, what is the advantages? It gives higher volumetric efficiency, which increase the power output. Means the volumetric efficiency is higher. Means suppose the total volume of the cylinder is a 0.3 meter cube, then it able to take more compared to the side valve engine. Flame traveling distance is reduced, therefore knocking tendency is increased. So spark plug is provided at the center, so flame traveling distance is reduced. Life of engine is increased, and exhaust valve is located in the cylinder head, not in cylinder block. So life of the engine is increased due to the exhaust valve is located in a cylinder head, not in the cylinder block. There are two designs of this type of the combustion chamber. One is known as the bathtub combustion chambers and second is known as the wedge head combustion chamber. So here you see this figure of bathtub types. It is a valve is provided at the center, so it's took like the bathtub shape here. Okay, and second is wedge head. Wedge head means it is a inclined edge surface. It is known as the wedge head types. Both of these are simple in construction, as both inlet and exhaust valve are placed in a single row. Means both the inlet and exhaust valve are placed in a single row. Means in a one line they are provided. The size of the valve are limited. To overcome these difficulties, engine will be designed with large bore and a small stroke length. Means diameter is larger and the length is smaller. Approximately stroke length upon the bore diameter is equal to 1. Means suppose the diameter is the 10 centimeters, then the stroke length is also a 10 centimeters. So both are same, then it is L by D ratio is equal to 1. So L by D ratio is equal to 1, though it is also known as the square engine. In bathtub type, valves are placed at the top and the spark plug is placed at the side, while in a wedge type valve are placed at the slightly inclined edge and the spark plug is placed at the top. Okay, so in a here spark plug is provided on the side, here it is provided on the top, and the valve is provided slightly inclined edge surface, here the valve is provided at the center. Now next we understand the F-head combustion chambers. So its shape is the F, that's why it is known as the F-head type combustion chamber. So here you see this is the upper part of head, this is a straight line and this. Okay, so it is known as the F-head combustion chamber. In this design, inlet valve is located in a cylinder head. So cylinder head means it is upper part. So this is our inlet valve, and exhaust valve is located in a cylinder block. So this is the cylinder block. So this exhaust valve is located in exhaust valve as shown in this figure. So this design is used by Willis Jeeps and Rover company. Inlet valve is located at the top with large area, which increase the volumetric efficiency. So you see that this area is higher, so more quantity of the fresh charge is coming inside, so it's increased the volumetric efficiency. Location of the spark plug is such that flame traveling distance is minimum. So spark plug is located on such a way that the flame traveling distance is reduced or it's the minimum, and high turbulence is created, so possibility of knocking is minimum. The mechanism is somewhat complicated. It is only the drawback of this design, means mechanism is complicated. So again we are required two camshafts for operating this inlet valve even as the exhaust valve, and design is also complicated. And its the advantages are high volumetric efficiency, maximum compression ratio of the fuel of a given octane ratings, high thermal efficiency. It can operate on linear air fuel ratio without misfiring. Means if the air is higher and the petrol is lower, at that time they are giving the good performance without the misfiring. Now next is the divided combustion chambers. So its name is suggests that combustion chamber is divided in two parts. So it is the main combustion chamber, this region, and this is the secondary chambers. Okay, that is a two chamber is provided, and the spark plug is provided into a secondary chambers. So in a main combustion chambers, the lean mixer is provided, and in a secondary, that is a rich mixer is provided. It is written here. Okay, so in this type of chamber, usually with about 80% of the clearance volume in a main chamber, means this main chamber have a 80% volume. Suppose engine have a 100 cc. Okay, so 80 cc is provided to the main chambers and 20% is provided to the secondary chambers. The main chamber is connected to a secondary chambers through a small orifice, and the combustion is started in a small secondary chambers. So this primary chamber and secondary chamber is connected by using the small orifice, and the combustion is first takes place in a secondary because the spark plug is provided in a secondary chambers. As the gases in the secondary chambers are consumed by combustion, pressure is rises and the flaming gas expand back through orifice and act as a torch ignition for a main chamber. Secondary chamber has high swirl and designed to handle a rich mixer. The rich mixers with very high swirl in a secondary chamber will ignite readily and burn very quickly. So in this region, the charge is burned very quickly and it is known as the secondary region. The flame gas expands through orifice, means the whatever the combustion gases is expands in this orifice and ignite the lean mixers in a main chambers. So this is the main chambers. So these gases is ignite the mixer available in a main combustion chambers. The net result is an engine that has a good ignition and combustion, and it operates mostly lean to give good fuel economy. Thank you for watching this video. If you learned and like the video, subscribe the channels and share with your friend.